have it if you pay. Okay. Yeah, because I was used to, I mean, it used to be you could edit things. There are a couple of other things you can add special effects, but you can't actually change the, like, delete things, and it is strange. All right, so I need my VM. Oh, how are you guys doing, by the way? Good. I'll zoom once I get in here. It's weird. I was feeling pretty energetic this morning. Now I'm really sleepy. Okay, so let's magnify. Okay, so I'm going to bring up Workbench. What do you guys think of Workbench? Yeah. What? You done? Right. Yeah, I mean the management, Microsoft's Management Studio, it's actually a shell of Visual Studio. It's part of their normal programming environment. It's fairly powerful. The only thing that I don't like in it is that when you make a diagram, it is live instantly, right? So if you're doing a model, that's a problem because as soon as you save it, the database is created. And you really want the freedom to be able to modify your design and mess with it and do things without creating the database. So that's one place where Workbench is better. Workbench, yeah, you can't do anything with the lines much. I'm going to add a new SQL window without all the old code. Now, unlike you guys, I have not actually put any data in my Python club. Actually, I was just thinking that I really need to make a version of these databases for myself so I could show you things. So I'm going to use the Sakila thing that's in here by default. It's just Microsoft has practice databases too that they use. This is sort of MySQL. With Microsoft, you can download AdventureWorks, which is sort of the one that most of the examples use. And they have a brand new one, which I forget the name of. It's for 2017. It has features that only 2017 has. But this is, so we have like actor, and we have, if I go down to film, there's the films, and then there's film actor. So this is really what this is kind of a dated in a way. It's sort of like a DVD store. I don't know that anyone actually I guess Redbox still is making it, but there are very few DVD rentals other than grocery stores, and because you can stream everything. In a similar way. Yeah, you probably do. That's true. Because you'd want to be able to search by actor and etc. So one of the things I just want to show you, I just opened an SQL window. And just like SQL Server, everything you do in the GUI translates into SQL. Right? Relational databases, the SQL is the language underneath that's doing everything. And everything that's in the GUI can be done with SQL. So that's the same in both. As I said, I think a long time ago, SQL is 90% the same across platforms. A 10% can sometimes drive you nuts, but the 90% is the same. So one of the things I'm going to do is I'm just going to use Sequila. Is that the name of it? Sequila. I don't know what that name means. Anybody know? Now, one thing that's a little different in this environment is that although it'll run if you don't do the semicolon, it'll throw errors. So it wants the semicolon. And if I execute here, down below it'll say, there'll be a green check mark, and it'll say use Sequila. Right. In SQL Server, I think it just says command successful. So just to show you, I'm going to do a select asterisk from actor. And I'll do a semicolon there. This is exactly the same as it would be in SQL Server, and it gives you, the result here. So we get the name of the actors. They're not real actors. They just made names up. Okay. That makes sense, and that hasn't changed at all. We just want to see what's in there. Just to show you, so I'm going to do select star from film, I think it's called. And I'll do this, execute it, and it has the film. And one of the things, so it just has all this information, special features, last update, release year, description, Academy Dinosaur, Ace Goldfinger. They made it all up. It's all pretty silly. Yeah, they did. Yeah. There is a channel. We get a lot of them. I have Xfinity. There is a channel that plays all those old 60s really bad sci-fi movies. Mm-hmm. They're usually pretty fun. Yeah, giant women created by radioactive something or other. Yeah. So if you want to be amused, you can read their description of the movies. So if you wanted to know which actors are in which movies, then they have, and again, this is just to show you the SQL, but I'm going to do from, I think, is it film actor? Yes, film_actor. And what we'll get there is just the actor ID and the film ID and then an update when it was last updated. So essentially that's a linking table, right? The linking table between those. So if you wanted to see which actors were in, say, the dinosaur film, we would need to do a join. And the joins look exactly the same also. So I will do that real quickly. We'll do a join between those three tables, just to show you that a join looks the same. So although I'm going to select specific fields rather than asterisk, I'm going to, and also notice that even though this is MySQL, and this is true even if you were on a Linux box, whatever, SQL is not case sensitive. Right? It isn't. So that's kind of a nice thing. The traditional way to do these is all caps, by the way. I'm lazy, I know. But it doesn't matter if they're all caps. That's just a traditional way to depict them. If I'm doing it purely in a text file, I do, just to show the keywords. So I'm going to select, so it's first name, last name, and then from the movie, I am going to select title. What else do we want? Let's maybe do description. What? What? Which one? It should just be in the. You have the. I mean, it's not super important because it's not the assignment. Yeah. So I don't see schema there. So when you download it, you can get the sample. There might have been a checkbox. But again, this is just to show the syntax. Anyone else? I think when you did the Windows installer with the whole package, it did the sample database. But so I'm going to do description. Anything else you want on this? Now let's just do release year. And I'll do the rating. Another thing about SQL is you can break the lines wherever you want. All right, so that doesn't determine the end of the statement. So just like before, this is coming from two different tables. One of the secrets with when you have a linking table, though, is that we're going to actually have to join not two tables, but three, right? Because we have to join the film to the linking table, and we have to join the actor to the linking table. So I'll start with actor, because that's what I started with up there. So I'm going to just say from actor. Okay, and then I'm going to say inner join film actor. And I have to say how they join. So I'm going to say on actor dot actor ID. Is that true? Let me look. Actor underscore ID. Equals film actor. There are some shortcuts you can do here, but I'm not going to do them because they would, I think, confuse it. You know, there are ways not to have to type everything. But all right, so that shows how those two join, right? Actor is joined to there. And then we need to join film. And we have to show how film is in relates to it by doing it basically on film dot film ID equals film actor. IntelliSense is only sort of here. Film ID. So we're showing the actor is joined with film actor by the actor ID being linked to the actor ID. And the film is linked to the film actor through the film ID. So it shows how the relationship goes. Basically just mapping that. And then I'm going to say, because we just really care about the dinosaur film, That one had where film dot film ID equals 1. That was the first film, right?
Yeah.
So let's run that. Okay. So these are all actors in the movie Academy Dinosaur. Right. Yeah. What? Yeah, we're not going to do that. Yeah. You think you're in well, yeah. So she was showing me that there are, besides inner joins, there are outer joins. And there's like a left join and a right join, and there's a full join, and there's a whole bunch of other joins that we're going to ignore for right now. They would complicate things, and they do a little bit different things. But 90% of the time, what you want is an inner join, because that's what shows the related data. For instance, like an outer join is actually specifically to find unrelated data. So, questions on the joins there? What? You did go through a linking table. That's why we have the film actor. Film actor is a linking table between actor and film. What? Well, so what we did is first we went from actor, right? So these two things are from actor. And these 3, 4 things are from film. But to get from actor to film, we have to go through film actor. So, and if I real quickly just run film actor again, what it has is the actor ID and the film ID.
So we're only using film actor for the join, and we're just requesting the data.
Right, you don't have to. If you have a linking table like this, so let's run that again. And the semicolon would be good. It usually only complains about the semicolon when you go to the next statement. The joining table, you don't have to pull any fields. You don't have to pull fields from every table, only the ones you want to see. But you do have to trace the whole path, the relationship path, right? And it's possible that you might want something in this table here and this table here, and there's a path that goes between them that has 5 tables in between. You might have to include all those 5 tables to get from there to there.
So when you do that, you just keep doing your join.
You just keep doing inner joins until you have everything accounted for so that you get the relationships that would give you the.
And then you can pull anything along the way as far as tables go. What you want.
Right, yeah. From any of those intermediate tables, you can pull whatever you want. There are some caveats in this. It doesn't matter too much here, but you can get duplicates. If one of the inner join tables has like several copies of the foreign key, it's possible. It really, where it matters most is if you're summing up totals and things. It can get to the point where you can get a wrong total, a false total, because it duplicates rows. So you have to be careful. I'm not going to spend a lot of time on that, but generally you can do as many inner joins as you need to get from point A to point B.
And so that's why sometimes it might say on film actor, or you can have different names for the foreign key.
You could. Now, if you have different names for the foreign keys, you don't have to do this. The reason this is that actor ID is in 2 different tables here. Actor ID is in actor, and actor ID is in film actor. The way we were doing it, where we let it write the foreign key name, the foreign key name is not the same name as the primary key. They're kind of, you can kind of see the relationship, but they're kind of there. If they're different field names, you don't have to specify the table. This is called qualifying it. So the table dot field name, and then table dot field name. And if the same field exists in multiple tables within that query, you need to qualify it. That's why I did film dot film ID here, because film ID is in two different tables also. If I take that out, I will get an error. I will show you.
I understand.
I just wanted to show that we'd, so if I run that, I should get an error. Basically, column film ID is ambiguous, right? Because it could be, yeah, you're not telling it which one. Yeah. And actually, for an inner join, it doesn't matter which one you use. Whether you use film or actor film, it doesn't matter where you get it from, because it's only showing matching data. It does matter in like your left join. It makes a difference. What? Oh, one is the number of the, if we do a select from film, we were interested in the dinosaur one. So the film ID one is Academy Dinosaur. You could also do where film title equals, and then in single quotes, right, Academy Dinosaur. I just was seeing if that's the whole thing. Typically, I mean, for a criteria, the ID works really well if you know it. If you don't know it, you could do the title. You could also do something where you could do, if you wanted to see, I kind of trying to find where to lower that a little. If you wanted, instead, if you wanted to see this film, if you wanted to see all of the films for a particular actor, so I'm going to run that real quickly. Let's say we wanted to see Penelope Guinness, all of the films that she was in. We could do actor ID equals 1. And it would show all the films that Penelope Guinness is in. So she's in Academy Dinosaur, Anaconda Confessions, Angel's Wife, Bulworth Commandments, Cheaper Clyde, Color Philadelphia. She's in a lot of films.
Can you use wildcard from where? Like if you're looking for, say, that it begins with PEN.
You could. So the way you would do that is you would do where I need the underscore. Can't type. So you would do like, and then it would be, I think this will be, so you want just PEN. I don't think case matters. %. See if that works. Oh, but we got Gary Penn.
You did last name.
Yeah, I did last name. And her first name was Penelope, right? So let's just change that to first name. But you see it worked.
Right. You do all the P's and whatever.
So if I run it now, for some reason, I don't know if F5 works or then we get Penelope. Do we get anyone else? She's the only one that starts that way. Actually, there's several different Penelopes. That's interesting. Yeah. This, by the way, is not a very efficient. It doesn't matter for like this or anything, but if you had a database with a table with, say, 30 million rows, which is not unknown, this could take hours. So it's not the most efficient way to search for a pattern. The other ways to do it involve creating full text indexes and things like that, which are a little more complicated. But for a quick look, this allows you to do. And the percent sign is the wildcard, meaning any number of characters.
Is that why they use NoSQL?
What?
Is that why they use NoSQL?
There are lots of reasons for using NoSQL. The main reason, which we'll talk a lot about next week, is that not all data fits neatly into columns and rows. You know, and it's also faster to capture things like just whole. And it does do better with large data sets because of the way, again, we'll talk about this next week, but relational database, the way you make it bigger is you buy bigger hard disks, right? With a NoSQL database, you can spread the database across thousands of files across the internet. You can do it on cheap computers. You don't have to buy massive hard drives. Drawback, when you query a NoSQL database, they never promise that you get 100% return. They just say that you'll have eventual consistency. What it does is it goes out, and this is sort of what Hadoop and all of that, which we're not going to talk that much about. It goes out and it does an algorithm where it brings back as much of all of that stuff as it can within a reasonable amount of time. So NoSQL databases are not very good for doing like business accounting and transaction type database stuff, but they're really good for capturing social media and capturing just kind of data on the fly. And they are much faster.
So real time.
In real time, yeah. I mean, you can capture a lot real time in relational databases too. I don't want to go too much off on a tangent, but think about cell phones. There are relational databases out there that are capturing every single phone call, text, every single message that's coming across your phone for every single account in real time, and eventually associating that with billing. Those databases, I'm sure, have hundreds of millions of records in every table.
But those are like old systems that are like hard coded.
They're hard, yeah. They'd be relational databases because they need to keep the transaction of everything that happens. And most of what's in the database would be just numbers. Be not very readable, right? It's just this number clicked here, use these cell towers to connect over here. The call lasted this long.
There's a whole bunch of different ones. I used to work with.
What?
There's a whole bunch of different ones. I used to work with.
Oh, you did? Yeah. I'm sure that there are a lot of them. I know that all the trains, the port has, and Sound Transit, they have massive database systems to track everything. Every bus has a transponder on it that's telling it where it is at any one moment. All that's recorded real time in databases. I mean, it's amazing what they do with databases.
Oh, so those new ones, so like the Metro bus, that's a SQL database.
Yeah. So when you get the like the Metro app says that this bus will be here in 5 minutes, yeah. That's because it's getting the transponder signal as it goes. And also when you tag in with a card, if the connection is good, it instantly transfers that to the database. If it's not, it has a temporary storage in those little things. And then when the connection is good again, it passes them on. As I said, they're pretty amazing what they do. Sometime I figure we'll all find out that wireless signals are cancer causing or something because we're bathed in them. Everywhere we go, we're just surrounded by wireless signals. So anyway, does the inner join make sense? It's exactly the same as we did it before. Notice there's no syntax change whatsoever. The like here too is exactly the same in SQL Server. So, trying to think. So the selects, the inner joins, the inserts are also the same. And then I also want to show you a little bit about updates. One thing I'm not sure. So there is a slight difference here, but it's a setting that you can change. But let's do an insert into, what do we want to insert into? Actor, because there's not much there. All right, and so we've got, now is the actor ID auto-numbered? Let's assume that it is, we'll see. And I don't know if the update is, it's a timestamp. I don't know if it's an auto default. Be nice to know a few things here. Small int. All right. Well, let's see what we get. All right, values. Anybody have a good first name for an actor?
Bobo.
Bobo, okay. Last name? No. Dodo, okay, Bobo Dodo. Sounds like one of the chimpanzee actors from a 50s movie or 60s. Now, the last update, I do not know if it will automatically do that. And this is something, I think it's current timestamp. Let's see if that works. I'll do the semicolon too. It seems to have done it. So let's do select star from actor. And we'll just look at the F5 doesn't work. I don't know what the keystroke is to run that. So we have to go all the way down to the bottom. And there's Bobo Dodo and the timestamp. Now, just like the inserts for, you know, what we did before, if you're doing an insert for like a new meeting and meeting minutes, you'd have to insert into minutes, then insert into meeting notes. You can only insert into one table at a time. You can insert multiple rows in the same table by doing instead of closing this, doing a comma, and then just doing the parentheses over and over again, right? You can do as many rows as you want, but you can only insert into one table at a time. And a lot of actions require you to insert into multiple tables. So you have to insert into one, insert into the next, and you have to get the foreign keys. I do not know if there's anything like getting the last auto number. Does anybody know? I would just do a select and look it up, but there might be. Well, it's not going to give it to me. I'd probably have to go online and look. Come on, why is that so slow? So I'm just saying get an last auto increment for a table in MySQL. I just wonder if there's a function. Select last insert ID, huh? Is it last insert ID? Will that work? So there's last insert ID, and there's also, you could get the max ID, which would just be the biggest ID, right? One of the things that you should learn, this is, what?
Which one had the check mark?
Well, this one had, let's see if I can scroll up. If you needed to get the new, if you had an auto in, you could do last insert ID. That's the function.
I'm sorry, I use Stack Overflow, and I don't trust them unless they have the check marks.
What are the check marks?
The green check marks, that means the answer is correct.
Oh,
But not ID is
I think that would be, what?
Save site, the check mark. Save site.
Let's go back. I want to get to, there it is. If we did, so we just did the actor, it's 201. So if we do select, what was that one? Last insert ID. And if I run that, it should return 201, right? And it did, it returned 201.
So what's right?
Yeah. So this will work. Or you could just go to a select and look it up for the next, if you have to insert into several tables.
Thank you.
That's fine. Just had a low blood pressure moment there. All right. So the insert should behave just like what they did before. The insert ID, if you needed to do like a film actor, if we entered a new film and do the film actor, you could use this, but it might be safer just to look it up. Just do a quick select and figure out what it is. All right, I want to show you this. We didn't talk about, although some of you did it last time. I want to talk about update. Update is a dangerous command. SQL Server has a little bit, not SQL Server, MySQL has a little bit of protection. SQL Server has 0. But if update can be more destructive than delete. Update can destroy a database. So, and I don't know if they have, I'm going to try something. Can't type. So it's not going to let me do a begin transaction. So that's SQL Server. It's one of those differences. But anyway, let's update actor. We want to change set last name equals. So what do we want Dodo to equal instead of Dodo? Dodson. Let's say Dodson. All right, now this is really crucial. If I were to run this like this, what would happen? Every single person in the database would be Dodson. And there's no undo, right? There's no undoing that. I mean, you can ruin a database. Usually, like I might show you in SQL Server because I know how to protect myself there. But in SQL Server, I usually change everybody's name to Smith and then make a dumb matrix joke. Remember the last?
Jurassic Park joke there, right?
Yeah, yeah. But I don't have a good Jurassic Park joke in mind. The Matrix is, the last really bad episode where Smith becomes everybody on Earth. Yeah. The thing is, you could get fired for that. And really the only way to undo it is to restore from backup. Right? There's no undo built into these. They assume you know what you're doing. So what you should always do, and this actually has some protections, because but they're optional. You can turn the protections off. It won't allow you to do an update or delete without a where clause. So I'm going to do, I'll do the where clause. So I'm going to do where actor ID equals 201. Now, one of the things that if you did like the Penelope one and you wanted to do that, you wouldn't want to say where the first name equals Penelope because there were like 4 of them, right? There was Penelope something or other, Penelope Gibson, and you would wipe them all out, right? So it's really using the key field if you can is best. So I'm going to run that. And the way that you know, so down here it says that it worked. And if you were to select from actor, actually let's just make it easier, where actor ID equals 201. All right, so if I run that, it's now Bobo Dodson, right? Update is for changing existing rows. Insert is for adding new rows. Update is for changing existing rows.
You change it. You change it back.
You only if you knew what you were. So I could change it back by going. Let's just do this again. I'm just going to copy it. You could change it to Dodo again by this way. That's the only way. There's no undoing it. There's no undo. There's no go back, except to rechange it.
If you change the many rows,
You're just screwed. There's no undoing it. The only way to undo it is to restore from backup. If you do not have a backup, you're totally screwed. One of the lessons of this, and I will talk at some point about security, it may be like a whole separate thing when we're done with other stuff, but you don't want to give your casual user update permissions. How do you avoid that? Because you do want them to be able to like change their email or something like that. What you have to do is you have to couch that inside of a stored procedure. So a stored procedure is SQL. That it's like several SQL commands put together that can be executed as one. One of the things in a stored procedure that you can do is you can demand before it ever executes, and it'll fail if they don't, that it has their ID. They don't even have to know their ID because you can get that from the website when they log in or something, right? And then it will do the update in the context of the stored procedure where you know all of the safety protocols have taken place. Basically, you want to control that. You don't want to give them straight update. Because if they have update permissions, they could do horrible things even by accident. Right? So generally, you don't give users update permissions. You give them access to stored procedures that do it for them. if you do the SQL class, we'll do some stored procedures. That's a bit advanced for where we are right now. But it's more like programming, because you're writing a little. You're basically writing a little executable script that does that. It's in SQL, but now if I wanted to change, so having run that, did I run that? You can run an update over and over again, actually, unlike, say, an insert. All right, so if I were to do this, it should be back to Dodo. So it's Bobo Dodo again. Let's do a little bit different variation of this. I'm going to do a comma here, and I'm going to go back to Dodson. And I'm going to say first name equals, and what do we want their first name to be? Maybe it was supposed to be just Bob. And somebody didn't like him, so they wrote Bobo Dodson. Bobo Dodo. And I also might want to update the timestamp because we are making a change. So I could say last update equals, and I could use that current timestamp function. So the way it stands right now, that it's Bobo Dodo 2017 and 10:51:40. So the time should change, the date won't. Notice where the I'm doing multiple fields in the same update. That's what I wanted to show you. All you have to do, you do set the first time. You have to use the word set for the first one. After that, it's just a comma to separate them. And you give them the values. So I'm going to run this, if I can select it. As I said, I haven't found the keystroke for this, although I'm sure there is one. So when I go, so I think it worked, yes. And then if I go back here, just to look and see where the status of it now, it's now Bob Dodson, and notice the time has changed a little bit. It's 10:53 as opposed to what it was before. Does that make sense? So that's an update statement. So we've done most of the CRUD. I'm going to do a delete real quick. So do you guys know what CRUD is? Other than the obvious. What? Well, it's actually, it stands for, so let's do it as all caps, because it's an acronym actually. Create, which is insert. Read, which is select. Update, which is change basically, and then delete. So those are the 4 actions you can do on data. Now there's other things you can do with SQL, like you could drop the whole table. You could, there's lots of different things, but in terms of managing data, CRUD, if somebody says you have credibility, that basically means that you can do all the things you can to data. You can create new data, you can read data, you can update data, and you can delete it. So the last part of this is delete, and delete is also a dangerous, it's actually less dangerous, if I can type, than update, because it won't let you delete certain things. It won't let you delete the parent that has children. Does that make sense? If you have an actor that is also has films, it won't let you delete them because it would leave what they call orphans. It would leave IDs that don't relate to anything, right? and your database would be meaningless. So you cannot delete a parent that has children. You can delete their children at will, though. Sounds very cruel, but you can. And if you delete the children, then you can delete the parent. Right. What? Probably, yeah. Explain.
You can delete the process. As a user, you can only delete the children.
Right, and then you can delete the process. Yeah. Partially for dependency reasons and just for the cleaning and exiting of things. But yeah, it's very much like that. Okay. So I'm going to delete from actor. And I'm going to run it this way without a where clause, which you should never do. But the only one that would be deleted if it were to delete anything is the one I just added. And I think within, let's comment that. It's interesting, it only commented the one. All right. I think it's going to give me an error. And not only an error because it doesn't have a where clause. So it tells me that you're using the safe update mode and tried to update data table without a where, right? That is just a option in MySQL. Most relational databases, they wouldn't care, they just delete. There could be another error. As I said, in the actor thing, it would have thrown errors because you can't delete the actors that have children, that have movies. Yeah.
I was just thinking if there is start transaction in this one,
Is there what?
like the rollback and begin transaction.
I'm sure there is. What I don't know is the what?
Start transaction.
Oh, it's start instead of begin.
Yeah.
Okay, that's good to know. I might do that in a moment. Yeah.
No, I didn't want it to.
No, that's actually good. I was looking for, I typed begin and it failed, so I didn't know. Yeah, start is good. Rollback or commit.
Yeah.
It has to be commit.
It was end transaction.
No, there's no entrance. It was either rollback or commit.
Oh, yeah, rollback.
So what you should do, I'm going to delete from actor where actor ID equals 201. So our Dodson should go away because it doesn't have any children, right? Because we added it, but we didn't add any films. And when I go down there, it says delete, and there's a green check mark this time. And if I were to do a select, it would just come up empty. See, there's no one there. They're gone. And again, there's no undo with a delete. The only way you could undo is you could go back to a restore from a backup, which is one reason why it's really important to do backups. All right, I'm going to try something. It may destroy the database, but I really don't care that much about the database. So I'm going to do start. Is it transaction?
Yeah.
Oh. All right, so I'm going to start the transaction, and it's actually, if you're going to do this, it's really important that you execute that. Don't just write it. Okay, so I've started a transaction. There are some bad things about doing this. So I'm going to update actor. And again, it doesn't care about that. I'm going to, now this probably won't let me do it anyway. This probably won't let me do it anyway. because it has that.
No, it will be, I've just done something after start transaction. If you give,
Well, so, but if I do say set last name,
you have to give anywhere as well.
now it generally, so it won't allow me to do this because of that setting, but I could say where actor ID is greater than 0. And that would be everybody, right? Again, you don't have to do this if you don't want to ruin your database. So I did that. So it is happy. It says 200 rows were affected. So when I do select star from actor, well, so it wants a semicolon. They're all Smith, right? Like the Bad Matrix movie. But because I did the start transaction, I can do roll back. Do I have to say transaction or just roll back? So if I run this, they should all come back. And execute. And they're all back to where they were. So a couple of things within a stored procedure, I talked about how you can do this. One of the things you can do in a stored procedure is you can do a rollback if there's any error or if the number returned is too big. Does that make sense? You could create your start transaction and your rollback or commit. Commit means write it, make the change. So you can have an if statement in there determining whether or not to roll back or run it forward. There are so doing this in a stored procedure is fine because all that happens in a nanosecond. But you know how I was typing while I did it? One of the things that start transaction does is it locks the database. So other people trying to do things, if you're having concurrence, lots of people are talking to the database at the same time, they're going to be hung because they can't do anything until you're finished your transaction. You've locked the database while you go through this manual transaction. Again, that doesn't matter in a stored procedure because everything executes in a nanosecond. But it does matter here. If I did start transaction and went off to lunch, the database would just be essentially offline for hours, for an hour or so, right? Because you've locked it. You said you're holding it there for this transaction. Once you've done rollback or commit, then it's back to accessible. So there's some dangers of doing this if you're in a real live situation, doing it manually. Doing it within a stored procedure is fine. In fact, that's part of your protections in the stored procedure. But in here it would be, you could slow things down a lot. However, I wanted to show you this because if you're doing it in your own database, again, you don't have a lot of data, but if you're afraid that you're going to make a mistake, you could do this to help protect yourself. Now, if you wanted to actually run it, let's just say, is there anybody I would change their last name to Smith? Let me just look at the actors. There probably is a Smith in here. Well, let's just do Penelope Guinness. Do we want to change her?
Yeah.
Okay, so let's do. So I'm going to begin the transaction. Again, you don't have to do this, but it's a protection, and with the drawbacks that it locks the database. I'm going to do this. So when I select from actor, you see that now it's Penelope Smith. If that's what I really want, now I can roll back if I want to go back to the way it was. If that's what I really want, I can do commit. So I'm just going to run commit. And once I've committed, it's that way. She is forever after Penelope Smith, and there's no undoing it once you commit. So you can't go back. I mean, I could do another update and change it back to Penelope that way. But there's nothing, there's no like undo that you can do. Just have to reset it. Does that make sense? So just to repeat, because I want to give you some time to work, and I've spent almost an hour talking about this. The select and the inner joins and things like that are all pretty much exactly the same as they were before. They're exactly the way they were in SQL Server. The only things that I've introduced are kind of the update and the delete. And the start transaction and rollback and commit are just things you can use if you want. They're not necessarily part of the assignment. Let me look at the assignment real quickly because I want to talk about a little bit there. This is already zoomed, so let me unzoom. So let's go to 220. I just wanted to look at the actual assignment. So let's go to modules. It's the easiest way to read these. And if we go down to, you guys have, if you're still adding data, that's fine. Just keep adding data. And then when you're done, the sample data and test, so the data is part of it. And there's not a lot of things there, you know, what out, oops, wrong one. MySQL sample data and tests. So one of the things you can substitute for these. I gave you guys a lot of latitude in terms of the databases that you created. So if you don't have something, you can substitute something else. Maybe just tell me stories. So list all the club members. I think everybody's got members or some version of that, right? So who are the club members? The events, you know, just, and so these are just lists of the events. When I say list, it just is basically a select. Resources, I think most of you have that. Now I said meeting notes. If you have meetings in the notes, you know, just do that. If you don't have meeting notes, just do something else. I said to add a new member, add a new event. I said to write a comment about a resource. That's basically if you had a table for comments. Again, if you don't, then maybe you can do something else for this. Just it's an insert. What? What? Yeah, review is fine. Review or comment or. And again, if you don't have this table, it's just another insert basically. And then I said to update a member's email address, change it to a new email address. So that's the only update thing. So these are not difficult, although again, if you haven't done any SQL ever, it might be a little, but I don't think they're very difficult. And again, what you want to turn in on this is just the SQL code, and ideal is SQL code with the answer table. But if it comes down to it, I could live with just the SQL code. And then what we will do next time is even if you're not quite done, because I'll try to give you some time to work on things too, but we'll start talking about NoSQL, which will be fun because it's very different. Questions, anybody? All right, so we've got about an hour. If that's not enough time, as I said, I'll see where people are, and I'll try to give you some time next time too. I'm going to kill the video and post it. I will also post the SQL here.